So hello everyone, I am back with another video. If you haven't watched my previous video, go there and watch the video. Video is already uploaded. Now in a previous class we have talked about this basic fundamental things like classification of rig, what are the types of rig, where the which type of rig has been used. So we have learned this thing in the previous video. We have classified our marine rig in the two types, bottom supported, floated rig, and their uses, where this rig is used. We have also classified the land rig into their based on their conventional, mobile, and based on the classification, their further classification we have done. We have already discussed about this thing, right? Now we have also discussed about the main component of the rotatory rig system, that is nothing but the power drive system, hosting system, circulating system, well monitoring system, well control system. So these are the all the component is we have already discussed. Now today we are going to discuss one of the most important component of the system, that is called power drive system and their calculation. Let's come to this power drive system. Yeah, we need to think, we need to work on this power drive system, right? So to perform the drilling operation we required a power, and this power is generated by the power drive system. So how they are going to generate the power? The power is generated by the they used to generate the power using internal combustion engine. Basically this engine is working on the diesel cycle. In this case they using a diesel, otherwise they use petrol also. So this cycle is basically used on the diesel cycle. So this diesel cycle is basically work on the four process, that is constant volume, reversible adiabatic compression, then the constant pressure heat addition, then expansion, and the, if I am correct, okay. So these mechanical people will tell you how this diesel engine is work. But in the modern era, they used to supply the power using the power drive, using the internal combustion engine, okay. And these engine work on the diesel engine, and that diesel engine is nothing but the working on the four cyclic process, right? So yeah, we don't have jump into that diesel engine part, right? Next thing we need to think about the number and the size of engine. Means to drill the particular depth, of if you want to drill the well up to 10,000 feet or 500,000 feet. So what will be the how means the number of engine, means how many number of engine you are going to use, and what could be the size of the engine, right? So if you want to drill the shallow depth, so it is depending upon the size and rating of the rig. I will discuss what is the meaning of rating also, so don't worry about it, okay. So rating is nothing but the means the how much amount of the compressive load can rig can sustain, right? So if you are drilling the shallow drilling operation, that is depth is less than the 5,000 feet, that depth is less than 5,000 feet. Typically they use two engine are used, developing a total power of 500 horsepower to the 1,005 horsepower. So if you want to drill the well which having a less than 5,000 feet, then that we can say that you require a two engine to generate that much amount of horsepower. And the power required, how much amount of power required? 5,000 to 10,000 horsepower, right? So if you are further want to drill the well deeper, in that particular case you required a 3 to 4 engine are used to capable of developing around more than 3,000 horsepower, right? So depending upon the use, you required a number of engine means one engine is required, or two engine is required, or three engine is required, depending upon the use, up to what depth you are going to drill the well, right? Next thing is the most important thing, power consumption means all the six component, what we have already discussed, all the six component they use to consume the power. the most of the power is consumed by these two system, hosting system and the circulating system. Later on we are going to discuss about what is hosting system and circulating system, so no need of worry about it. But the beauty of these two system are, they are not working simultaneously together. Means if one system is running, the another system is stopped, and when the another system is running, the another system is stopped. Means when the hosting system is running, at that time, means circulating system is stopped, and when the circulating system is running, that time hosting system is stopped. So the I am saying that the most of the power is consumed by the hosting system and the circulation system. So can you imagine, if the both the system is working together, they will consume more amount of the power. But the beauty of this operation is, or are, that the both the system is not operating simultaneously. So both the system not operating simultaneously. This is the beauty of this system, right? Means one is running, the another one is stop, one is running, the another one is stop. So this is how the things are there, right? Now the total power requirement based on the literature, or based on the what you call, based on the reference book or textbook that I have chosen, it is written over that the power required for a rig system is generally reported as 1000 to 2000 horsepower. This much of the power is required nowadays to drill the well, right? It could be more than, but the average it is reported in the literature, right? So the next point is the power flow on the rig. So this is the flow path, how the power is transferred from one system to another system. Like a diesel engine, the main power source, that power source is the goes to the power generator, then the power generator to the distributed to the rig system, and the consumer. Who is the most consumer? Hosting system and the circulating system. These are the key points you can remember if you want to know anything theoretical things, right? Modern rig used IC engine, that is nothing but the diesel engine. If you have a shallow depth, then you require 5000 to 500 to 1000 of horsepower. If you have a deeper depth, then the more than 3000 of horsepower required. Most of the power used by a hosting and the circulating system, yeah, these things I've already discussed. These two systems are not operating maximum load simultaneously. Means, yeah, we have already discussed, we don't have a, these two systems are not operating simultaneously, means the continuously together, right? And this power required, it is reported in the literature, right? So this is all about this slide. Okay, if you have any doubt, you can comment it. I will definitely going to so now let's move to the another slide. That slide is nothing, yeah, that slide is, yeah. So as I discussed, this is the power drive system. In the power drive system, basically, yeah, there is some calculation. If you talk about the definition of power, if you talk about these things, so power can be written as force into velocity, force, and this velocity can be written as distance by time, right? But in this case, this formula is valid for the linear motion, but here it is the circulation motion is there. That's why the power is written as P is equal to W into T, where W represent angular velocity and T represent torque. This is the pictorial diagram that is simply indicating that this is the circulating motion they are giving, and they are trying to lift this much amount of the force, or you can say load, and with the v velocity. This is the representation of a power drive system. And yeah, this is the representation. There are basic fundamental things. If you talk about this, force is written in the Newton, this velocity is nothing but the meter per second. If you want to write the unit of the force, Newton meter per second, this is the unit of power, but this is unit in the SI unit, right? But as I discussed, we are dealing with the field unit, right? In the field unit, it can be further the The in the field unit, it can be written as in the form of, let me write, I have already written. Okay, so in this case, power drive system, it is written as a W into omega into T, and this omega is nothing but the angular velocity, which is written as radian per second or per minute. It's up to you, depending upon the which unit you are writing, radian per minute. And this torque is written in the form of, what do you call, if you want to write in the field unit, if you want to write in the field unit, in that case you can write lbf feet, and this is written as, yeah, if you divide this thing you will get this thing, right? So yeah, so this is the things, and these are the basic calculation. If you have any doubt, this is W is equal to something, and the W can be further written as 2 pi n. 2 pi is the circular rotation, n is the number of revolution, means in 1 minute or 1 second how much amount of revolution your circulating disc or whatever the things are there, they are rotating, right? Yeah, this is all about this thing. Yep. So let's jump to the next slide. And yeah, this is the things we want to discuss. As I discuss about this thing, as I told, that power is written as power can be written as W into T. Power can be written as W into T. As I discuss, this power, the basic unit of the power is lbf, pound force feet per minute. Okay, pound force per minute. This is how the things are there, right? And this omega is written as radian per minute, right? Radian per minute. And this torque can be written as, uh, lbf feet. So this is the things. So this is how the things is written as, right? But this is the representation in the petroleum engineering, right? But we, in the power, we can also express this power in terms of a horsepower, right? So we need to remember that the 1 horsepower is equal to 33,000 lbf feet per minute. So at the end we need to convert this power into the horsepower. So we need to remember this basic fundamental unit conversion. So this is the output power we will get. This is the output power we will get, right? Now what about the input power? What about the input power? So we need to think about it. Input power, we need to think about it. What will be, we are going to get it, input power, right? So yeah, very basic thing we need to understand. We are running, generating the power through engine, right? And engine is consuming some amount of fuel. Let's understand this thing. How can we are going to, how we are going to understand this thing? Let's suppose you have a bike, one bike you have a Splendor, another one you have a Royal Enfield. If you compare the mileage of Royal Enfield and with the Splendor give you the more mileage, and Royal Enfield give you the lesser mileage, right? So what does it mean by mileage? Means the your you in 1 liter they will cover 55 kilometer. Let's suppose a Splendor it is, and if you have a Bullet, then it will give you 30 or 28, maybe or 35. So means their power consumption means they are consuming the power, and they are giving the some amount of they are giving distance in terms of a, right? So here it is, in the engine. When you talk about the engine, Q can be written as, Q is written as, Qi is written as Wf multiply with the H. So Wf is nothing but the rate of fuel consumption, means rate of fuel consumption. lbm, mass per second or per minute. Yes, mass per second or per minute, right? So how much quantity of fuel they are consuming every second. And this kh is the heating value, h is the heating value. So heating value is the means, let's suppose you have 1 kg of a coal, 1 kg of a coal you have, and 1 kg of a wood you have, right? If you burn, right, so which one give you the more heat? I can give you guarantee the coal will give you the more heat compared to the wood. So their heating value. Similarly, if you observe this in this table, you will observe the diesel, gasoline, butane. So everyone having heating value greater than that, means methane will give you the more heating value comparatively to this, right? So if you multiply this thing, means in every second how much amount of fuel the engine is consuming, multiply with their heating value, they will give you the input power. Simple, simple as simple, right? Very simple mathematics is going on. If you are continue with my lecture, you will get the simple mathematics, right? Yeah. So finally everything is evaluated on the basis of efficiency, that is power output by power input, right? Et is power output by power input. There is another important unit conversion is there. 1 BTU is equal to 779 lbf feet, right? Am I right? lbf per feet, right? This is the conversion. You need to remember this thing, right? Now if you move to this table, if you in the left side, the types of fuel is given in this corner: diesel, gasoline nothing but the petrol, butane and methane is given, whose density is also given, lbm per gallon, and whose setting value is also given. So these value and these value will help you to solve the numerical, right? So before jump into the numerical part, let me remove this thing. So yeah, let me go to the numerical part. Yes, yeah, this, yep. So yeah, this is the question that I have bring. Yeah, so a diesel engine given on output power, output torque is given in the question. T is given, that is 17400 feet lbf. Next thing, at an engine speed n is given 1200 rpm, revolution per minute, rpm minute. If the fuel consumption rate, remember fuel consumption rate, wf, 31.5 gallon per hour, right? This is also given. What is the, this is the given data, and this is the finding, what you need to calculate. So what you need to calculate, p output you need to calculate, and et overall efficiency you need to calculate. So yeah, if you are able to understand the previous concept regarding this, so then you can easily do this calculation part, right? Yes. So we just now we have calculated the formula for the power output is nothing but the W into T. So W into T, W can be further written as pi n into T, and this can be further written as 2 pi n value is given in the question, and torque is given in the question. Torque is 1740. Am I right? Let me do the calculation so that you can get exact answer. 1200 multiply with the 1740. Yeah, so the value you are getting, power output you are getting 1311990.92, and the unit will be, if you remember, this is given in the radian per second, the unit will be lbf feet per minute. This will be unit, but as I told you that power we need to calculate in the terms of a house power, hp. So yeah, there is a unit conversion. 1 house power, 1 1 horsepower, 1 horsepower is equal to 330000 lbf feet per minute. So can I write 1 divided by 3300 hp, which is equal to 1 lb feet per minute? Okay, so in place of this we can write, this. Yeah, so in terms of this we will get 1300929021. So 921 divided by 133, sorry, double triple zero, yeah, is equal to horsepower, right? Yeah. So now if you divide this thing with 33000, you will get power output is equal to, so 397.55 horsepower, right? This is the output power you have calculated, and which is in the horsepower unit, right? First part is done, right? Now we need to calculate the et. Let me remove this thing. If so, simple basic calculation is there, right? So you need not worry about it. If you solve 2-3 more numerical, you are expert or solving this question, right? So you will obtain, let me write this value, because 39755 hp is the first answer of this question, right? Next point, the next one thing we need to calculate et. So et is nothing but the p output by p input, right? P input. So output I have calculated. P input is nothing but the qi is nothing but the wf multiply with the heating value, right? So wf, as I discussed, that the wf is the mass consumption, but it is given in the volume consumption, volume per hour. So what I need to do, let me give you the brief example, right? Suppose you know the density is equal to, can I write wf by v? If you multiply, wf can be written as density multiply with the v. So density multiply with the v, and density, which engine they are talking about? Diesel. So if you are smart enough, the density of a diesel is given as 7.2 lbm per gallon. 7.2 lbm per gallon. 7.2 lbm per gallon, and it is volume is given in the 31.5 gallon per hour. So gallon will cancel out. You will get what value you will get? 7.2 multiply 3.15, you will get 2268 lbm divided by per hour. So are you getting my point? So you got the lbf, now it is mass consumption per unit hour, so you get the wf value. Now heating value, qi is equal to 226.8 multiply with the heating value. Heating value of diesel will be 9000 btu, I think, btu per lbm, I think. Let me 9000 btu per lbm. Yes, let me yeah, okay, let me remove this thing. Yeah, so this is in the lbm per hour, and the unit 9000 triple into btu per lbm, right? So this lbm will cancel out. Now you will left, yeah. So let me do the calculation for better understanding. Multiplication we need to do is 190000. You will get qi is equal to 430920000, right? Now you have which unit? BTU divided by hour, right? Let me give you one basic fundamental things you people like the most, yeah. Okay, so let me erase this side so that we can do further unit conversion. So we, if you remember that 1 BTU we can write this thing. So can I multiply this thing? If you agree, 4309200 multiply with the 779. Now it is lbf, feet per hour, right? Now if you are smart enough, if I have to convert into the horsepower, so can I write 1 horsepower is equal to 3 divided by 3,000 is equal to lbf feet per minute, yeah. But here it is in the hour, so we know that 1 hour is equal to 60 minute. So these all term is goes into the denominator. So without any further ado, so I want to write this thing over here, so don't confuse. 4309200, oh sorry, 00 multiply with the 779. These all term will be in a denominator, 3300. From this it will convert into HP if you multiply with the 60. So now do this calculation, you will get Q input in the, let me do the calculation. It's an enormous calculation. So 4309200 multiply with the 779 divided by 33000 multiply 60. Yes, so you will get the power input finally 169538 house power, right? You will get it. So input power you got this value, let me write Q input is here 169538 house power, another input power. Now what we need to calculate? We need to calculate ET. ET is efficiency. ET is efficiency, right? Okay, so ET is efficiency. So this is nothing but the output, P output by P input. So output we have 39755 divided by 169538. So you will get some value 397.55 divided by 1695.38. so you will get the efficiency 0.234. so ET will be 0.234. okay, if you, so this is the another final answer. So in upcoming class I am going to talk about the more numerical.